Hi everyone, this is Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. In this lecture series, today we're going to see about the Armstrong Axioms for the functional dependencies. Similarly, how we are taking the properties in the mathematical concept and all. Here, under the functional dependencies, there are 7 axioms. So your primary axis, through primary axiom, we can able to create a secondary axioms. So in primary, we are having 3 different types of axioms: reflexivity, augmentation, and transitivity. By using these 3 theorems, we're going to develop the secondary part, that is union, composition, decomposition, and pseudo transitivity. Let us see one by one. So axioms of reflexivity. Reflexivity is nothing but your mirror image. So whenever it can be reflected outside, that can be called it as a reflexivity. For example, if y is a subset of x, then we can say x determine y. If x determine y, x itself can determine the y. So x itself can determine the x. So this type of a property only we can call it as a reflexivity. For example, here you're having a roll number, name, marks, department, and course. Each and individual attribute can determine by itself. This type of a property we can call it as a axioms of reflexivity. Example, we can say your roll number can determine roll number, name can determine name, mark can determine mark, department can determine department, course can determine the courses. These are the examples of axioms of reflexivity. Second thing is axioms of transitivity. Transitivity is nothing but, in the previous video itself, I have explained about the transitive functional dependency. The same thing here also. If X determines the Y, then we can say Y can determine the Z. Indirectly, X can also determine the Z. So see through that, Rom is a sibling of Sham. Sham is a sibling of Morgan. Then we can say, without anything, by using a transitivity property, I can say Rom is a sibling of Mohan. So this type only we can call it as a transitivity. For example, here name tends to marks and marks tends to course. So through that, I can able to say name tends to course. So this is the indirect relationship associated over here. So this type of a thing only we can call it as the axioms of transitivity. Second thing is augmentation. Augmentation is nothing but this common attribute can be added at the both the sides, both LHS as well as the RHS. That is nothing but the both the determinant and the dependent. So these type of an augmentation can be called it as a partial dependencies. So in an augmentation, X determines a Y means X determines a Y, X Z also determine the Y Z. So this type of a relation only we can call it as a augmentation. For example, roll number tends to name. Then we can say roll number and mark tends to name and mark. So these are the simple example for the augmentation. So these are the primary rule. By using a primary rule only, we're going to generate the secondary rule. So in the secondary rule, first is called union. You generally we well known about the union. Union is nothing but the combining all the components. So what are the elements present in both the table? If you are joining together, that operation only we can call it as a union. Similarly, the same thing here also follow. If X tends to Y and X tends to Z, we can able to write it because my LHS side is both will be the same. So then I can able to write X tends to Y Z. My RHS component are joined together. Similarly, see here, roll number tends to name, roll number tends to marks. Then I can say roll number tends to name and mark, because by using roll number, I can able to identify name. Roll number, I can able to identify mark. So by using a roll number, I can able to identify both name and the mark. Then only we can call it as this is the axioms of union. The next thing is a decomposition or a splitting rule. It is also called as a project rule, or it is a reverse of the union rule. If X determines Y, then X determines the Y, then X determines the Z separately. For example, X can determine Y Z. So it can split the two component, because in my RHS it will have a two attributes. So that we can write it as a X tends to Y and X tends to Z. So most of by going for the property bigger problem and all, if you want to split the table or split the attribute, we can use the splitting and the decomposition rule. So through that, we can able to separate my RHS part, not LHS part. So name tends to name and mark tends to department and course. Then name and marks tends to department, name and marks tends to course. This is how we can able to split the thing. So this can be called it as a decomposition. So the next thing is a pseudo-transitivity. Pseudo-transitivity is nothing but it is also an indirect property, but little bit there is a change. If X determines the Y and Y Z determines the W means X is Z. X, because here it is a Y is a component. So we can remove the thing X is Z through X is Z, we can able to determine the Y. This is the extraordinary attribute that will be removed over here. So through that, we can able to identify X is Z tends to W. Similarly, roll number tends to name and name and marks tends to department. This means that roll number and marks can determine the value of the department. So this is the how a pseudo-transitivity property can works. So the next thing is a composition. Composition is nothing but adding a different component on both the sides. For example, X tends to Y and A tends to B. We can able to combine both LHS part as well as the RHS part. Through that, we can able to determine XA tends to YB. This is my determinant. This is my dependent. See, through that, roll number tends to name and marks tends to department. Then I can say roll number and mark. Through roll number and mark, we can able to determine name and department. So this type of a thing, we can call it as a axioms of composition. So these are the various primary and the secondary rules. So by using a primary rule, we can able to easily determine or we can prove the secondary rule. Thank you for watching my video.